In Smiths Falls, Ontario, there's a Bascule bridge that was built for the Canadian Northern Railway in 1913. It's been out of service since 1979, and today it's parked at about 45 degrees to allow boat traffic on the Rideau Canal. Here's a picture of what it looked like in September 2018. After decades of seeing this strange looking bridge from the highway, I decided early in 2018 to look at the possibility of modeling it in HO scale. This close-up shows the confusing array of beams, struts and gears that make it a challenging structure to model. So I decided to build a simple wooden model to understand it better. Here's the wooden model of the Bascule Bridge, which I built before doing much work. I'll show you how it works. If a small motor were to apply a force on the axle at this point here, you can see that the bridge rolls and the span rises. And of course, it comes down like that. All the while, this center of the quarter circle is at the same height, that is the radius of the circle. So this model is made up of two parts. I'll separate them. Here's the basic frame. The axle runs along this level and the quarter circle runs on the tracks at this level. This is the moving part of the bridge. There's the quarter circle, its center. This would be the counterweight here, concrete mass. Of course, this is the span. And the two of them sort of fit together like that. And you saw how it works. So when I understood these real basics, I decided, okay, I'm going to proceed and spend some money on materials and redesign this thing. The model has three spans, basically, the left and right fixed span, and of course the moving span that is connected to the quarter circle, the rolling portion. I built each of these very similar to the real thing, shaping 60 thou styrene sheets into I-beams and plates and other detail. I've attached a top and bottom view of one of the spans here. Many weeks later, you can see the three spans all sitting horizontal in this photo. Fanciful because the BC Rail RDC never would have been on this particular bridge. You can also see the construction of the rolling part with the counterweight sticking straight up in the air. Also, if you note, in that vertical portion on the right-hand side, there's a little black piece in this black and white photo. That's a limit switch, which, because it's a motorized bridge, shuts off the motor when that part flops down and sits horizontal. And of course, then the span of the bridge is close to vertical. In this view, the span is raised and it shows the underside, including a second limit switch that controls when the motor shuts off as the span goes down to the horizontal position. The next three pictures show the bridge in various situations, but after I've painted it, but hopefully showing its grimy, rusted structure as of 2018. One last point of interest before I show you the video of the bridge working is this information on the side of one of the guardrails on the bridge. Although the bridge was built in 1913, these guardrails were manufactured in 1889, and they're 56-pound rails. So I doubt, well, not doubt, I know they haven't been changed since. The main rails on the bridge, however, have a date of 1955 on them, so no doubt had been changed several times in their history. This brief clip shows the span coming to a horizontal position, and you can see the limit switch with the little red roller on it on the end of an arm. When it's compressed enough, it opens circuits and cuts off power to the motor, and that's why the bridge stops without trying to drive itself further into the ground. The final clip is about a 2.5-minute video of the bridge rising and then going down. There are a few brief stops because of some unresolved little electrical problems. It could be just dirt, but you'll see where I'm referring to. So the bridge proceeds up, and you can see, if you look carefully, the limit switch on the right hand side getting compressed and then causing the bridge to stop in an upright position. At that point, off camera, I have a little switch that reverses the voltage to the motor, and when I flip that switch, the bridge starts down, and it goes down quite nicely right till the very end, where it's nearly horizontal. The other limit switch is being compressed, and again there's a bit of an unresolved electrical problem. Again, it could be dirt, some contact problem. But it finally continues and shuts off. So the next time I update this video, I'm going to deal with the problems of having power to the rails, particularly the rail on the moving span. So that's it for now.